Tuesday. It's my favorite day of the week because this is the day when we get to talk to awesome people from the hardware creator community. Today, we have Kwabena Agyeman, who is the president and co-founder of OpenMV and has been bringing open computer vision and machine learning to microcontrollers for over 6 years. What's up, Kwabena? How are you?
Hey, how's it going? Thanks for having me on.
So excited. Tell us a little bit about OpenMV. What's your deal?
Yeah. So I am the president and co-founder of a company called OpenMV, and we make this thing called the OpenMV Cam. More or less, this was a project started to see what can be done with all the high-end microcontrollers that have been coming out lately and how to get computer vision running on them. We started off with the STM32F4 processor about 6 years ago, and now we finally upgraded to the STM32H7, and we're starting to add DRAM to the camera system and a bunch of other things. And it's starting to look like literally a old school Pentium computer, but a microcontroller more or less, where you have control over the whole system. And it's more or less a combination of software that's doing the vision algorithms and the drivers that are capturing the image. So it's like a full development and experience and controlled experience where you can capture image data, process it, and do everything from the ground up.
Right, because besides the hardware, you also have the OpenMV IDE, which works with a bunch of different hardware, including stuff that you manufacture, but also other things.
Yes. So so basically the system works with it's C code that runs on a microcontroller, and we have the MicroPython operating system as the user interaction layer. And so that allows you to program the OpenMV Cam more or less in Python, and those Python calls then execute low-level C library calls that actually do the work. And this allows you to more or less have a pretty fast pace of development. And then we're always pushing out new features in the firmware updates that we push out to the system. And so when you're programming it, you program in Python, and we have an IDE that enables you to quickly iterate when you're doing that.
Super cool. Now, what's your latest hardware about? If people go to your website, they will see this OpenMV Cam H7, but that's old news now. What's the new hotness?
Yeah. So the H7's been out for about 2 years. It's been selling pretty well, actually. So interestingly enough, what we actually have been doing is something that I think a lot of people don't think about, but optimization. It's actually the case that we left a lot of performance on the table with our current processor, and just by getting into the data sheets and utilizing things like the DMA controllers, and the fact that the processor can do a little bit of SIMD magic, which allows you to double pump operations, more or less getting you 2x per pixels processed per clock, and then also just improving the algorithms. We've actually been able to dramatically improve the performance of most of our firmware by more than 2.5x since we started working on this processor.
Wow.
So it is like the same hardware per se. We've been unlocking a lot of features that dramatically improve the speed and processing power of what we're actually able to do. An example, we just finished optimizing something called JPEG compression. This processor has a JPEG compression core in silicon, but normally the C code that was given to us is for the development environment that's provided by ST Microelectronics. That default C code feeds the JPEG processor with it manually has the main CPU writing a byte at a time of image pixels to the JPEG core. And when we looked at what this code was doing, we realized that the main processor was spending most of its time sitting there writing data to the JPEG core and not actually doing real work. But ST had developed in a direct memory access path where you could just pass a buffer, a pointer to a piece of memory, a memory location, and DMA then would turn on and feed the JPEG core without you having to manually do this. And so once we finished, optimizing some code lately, and we're just getting that merged in right now. This actually boosts the JPEG compression performance by 2.5x. And yeah. So it's literally like We are, I think when we started so far through the optimization process, we have improved the performance of that original code by about 5 times now. And
Wow.
so if you think about it, it's like we've gotten, just through these optimization processes, we are effectively getting a new H7 that's faster and faster every couple of months as we release new firmware updates.
Wow.
Mhm.
Pardon my noobery. I'm curious, is the JPEG core inside is that an FPGA or is that just like a part of the
Oh, it's a part of the silicon.
Oh, okay.
So ST added a JPEG compression core, and the JPEG compression core is actually incredibly fast. It can
Hmm.
JPEG compress very, very large images in a millisecond. However, ST forgot to add a piece of hardware that enables you to feed it
Oh,
data
yeah.
without the processor manually doing that. And so the
That's where the
processor
DMA
has
comes in.
to do a ton of work reformatting a regular image into
Mm-hmm.
something called a 8x8 JPEG MCU,
Huh.
which wastes a lot of processor time, but that has to be done in order to feed the JPEG compressor. What they did do, though, is they have a hardware accelerated decompression path because ST designed this core mainly so that you can get a memory stream where you have like a video coming off of the SD card, and they designed everything such that the processor has to do no work to decompress JPEG images to display them on a stream.
Yes. Cool.
So if you were going that direction, you could do 1080p images with almost no processor interaction. But on the encoding side, they didn't really do much hardware acceleration for that. So the processor has to get in there and do most of the work.
And I want to jump into your PureThermal stuff, but also you just mentioned displaying on a screen, and I noticed while digging through some of your info on your site that you can wirelessly display from the OpenMV to a screen.
There's a few things that you can do actually.
It seems so powerful.
So yeah. So we just recently finished again, the optimization process has actually been really big, and I'm really like pulling out performance of hardware that previously no one was doing. So for example, we have this thing called the TV Shield.
Hmm.
It's just a standard NTSC output. Let me see if my camera focuses on it. Nope. Anyway, we saw 2 versions of this. One that has a nice NTSC analog output, and then one that actually outputs to one of those FPV broadcasters. No, the other one. Go back. Go up. You see the thing top right? Yeah, right there. That one.
This
With a
guy?
little, no, down.
This guy.
Yeah.
Oh.
Yeah. So this allows you to do, since we just got done with an update to the TV driver last month, and so this allows you to do a 352 by 240 image, updating at 60 hertz
Wow.
over Wi-Fi. Sorry, not over Wi-Fi, over 5 gigahertz FPV spectrum. So you can like add those goggles, you can put on FPV goggles, or
Like
just a
for
regular
little drones
LED
and stuff,
screen.
but have
Yeah,
it look cool.
yeah. And so this is the way we developed this driver. Previously, it had been the main processor was manually modifying the pixels and then putting those and then sitting there on the SPI bus and sending that data out. And previously, we were only able to do 160 by 120, and it took up a lot of processor time. And so we just finished redoing that driver with support with DMA hardware acceleration. And so now we quadrupled the resolution, and we added some SIM decode in there to double pump the pixel operations in order to convert the image from RGB 565 to YUV quicker, which is what the TV Shield needs.
Huh.
And so that improved the speed of it outputting. And then the DMA means that the image can be basically converted by the processor really quick in memory. And then the DMA will manually feed the SPI bus while the processor goes off and does something else. And so this allows you to output that video without any load on your main application.
Amazing.
So like you can be processing another image while the previous image is being written out and displayed to the screen.
Such parallel. Let's jump into the exciting new thing. Tell us about the PureThermal OpenMV. And everyone, we'll put this link in the description to this video. You can go and sign up to be notified when this launches on groupget/Hackster launch. It's going to be very exciting. Yeah, what's its deal? What do you got there?
Yeah. So this is the It's upside down. This is the OpenMV Cam PureThermal. This is our first rev of the hardware. We just got a second rev back.
Ooh.
We added one extra feature for the second rev. So on the first rev, we didn't have a distance sensor. Man, I wish my camera would focus on this. There you go.
Oh, there we go.
Yeah, boom. So this is our most aggressive and advanced OpenMV Cam. And when we started this project, where we're like doing, it's just literally we had a microcontroller, right? And that was the only piece of silicon really that was interesting on the board. And now we've really kind of branched out and are doing more interesting things. And if you think about what like a Raspberry Pi like computer looks like, we're starting to get into territories where we have like Linux-like computer capabilities, but still with the ease of use of MicroPython. So you got the main processor right here, the STM32H7. This is the largest package they have, so we broke out every I/O pin, so 168 I/Os.
And you're using every single one, right?
Yeah, we're using every single I/O pin. And that's what's cool is that we've actually built our OpenMV Cam firmware that allows you to really take the firmware and target any new board. So it's the same firmware running on all of our different platforms, but we've just modified which pins go where and what's connected to what in the config file. And this allows us to like target lots of different hardware pieces while maintaining the same core firmware. Anyway, so yeah, we've got 64 megabytes of SD-RAM attached to this guy for 400 megabytes a second of memory bandwidth. It has a Wi-Fi chip there. We decided to use, so with the Arduino Portenta, we finally upgraded to be able to support SDIO Wi-Fi using the Murata D1X. And so that allows you to do like, 50 megabits a second. But for this particular board, we didn't want to have to go through FCC certification because that module is not FCC certified, so you have to do a lot more work. So we're just going to use this WinC one. It's not as fast, but it'll get you about 12 megabits a second of Wi-Fi without us having to do a lot of certification work.
Yeah.
And then over here, we have a new chip that I think a lot of people don't know about, but it is something called the TFP410 panel driver. And more or less what it allows you to do is take a 24-bit parallel data bus that will drive an LCD and turn that into HDMI. And so, yeah, the OpenMV Cam now can output HDMI to a TV or screen. We added this so that you have the ability to do display mirroring, more or less, on the OpenMV Cam PureThermal.
So you can get the thermal image in that.
Yeah, it has.
Oh, look at that.
Yeah, it has one regular display. So this is an 800 by 480 LCD screen. And that's going to do 60 hertz, more or less update. And it is also 5 touch point touch screen. And we already have all the drivers written for you to be able to touch the screen and get, status of where something is touched. We don't really have a GUI library. I'm not quite sure what our solution is going to be for that. There is a MicroPython-based GUI library called LVGX or something. But we're probably just going to release this thing with just more or less basic driver support and then see how people utilize it. But yeah, no, we have that screen. And so what's neat is that, the hardware automatically handles, the STM32 chip has, for example, a bunch of hardware acceleration to do LCD panel driving. And so the whole process of sucking data out of SD-RAM and then, outputting it to the screen and outputting to HDMI is completely hardware accelerated. So that all happens, like the processor just drops off. All it does is update a memory buffer with the new screen image, and then it just changes a pointer, and boom, the new image is displayed. And so there's zero time being blocked while you're updating the image. And so that the whole screen output thing just works seamlessly in the background, and it's just buttery smooth.
That's beautiful.
Yeah, it's really not like once you start getting into like utilizing these processors, you realize that they're actually quite powerful. Finally, it has quad SPI flash, so 32 megabytes of that for storing like configuration assets or some neural networks, and you can also attach a SD card. And we support exFAT, so you are able to attach like. This is a 512 gigabyte SD card. So there's really not any limit on how big you want to make that. And then finally, we have the OV5640, which is a 5 megapixel webcam. And it also does, besides being 5 megapixel, it has autofocus. And it also has
Yeah.
the ability to do strobed trigger modes. So you can like trigger the camera via software to take a picture at a particular time. And then we also have a high brightness LED, so you can actually take precision flash images. And then finally, FLIR lepton support. And so that's right next to the camera, and that allows you to basically do combined thermal images and color images in one go.
And can you swap out the FLIR lepton, or is there a particular one on there?
You can swap it out. It's just a socket, and so we support any FLIR lepton, the 1, 2, 3, and the 0.5 versions. And then what we did for the second rev, though, of the hardware, besides fixing a whole bunch of bugs, so you see no more wires there, is we added a distance sensor right next to it. So it measures up to 2 meters. And the reason why we added that distance sensor is so that you can actually, you'll see in this demo I'm about to show. So when you're trying to, get the, by the way, you see how my camera's like autofocusing? You'll be able to do that with the OpenMV Cam PureThermal.
I looked at your demo of that. There's already, if you go to their YouTube page, which is in the description already, you can see this cool autofocus experiment with the camera that's on the new PureThermal board.
Yeah, no, it's pretty sweet. Just having this kind of ability built in and you being able to command it. No, the reason why we added the distance sensor is that there's like this parallax effect when you have two cameras looking at an object. Like if the object is close, like for example, just look at my hands. You see if I move one hand backwards, it kind of slides. It's not like it's moving perfectly backwards and it gets small, it kind of shifts also. And so because of that effect, you need to be able to actually measure the distance of the object you're looking at in order to kind of like scale and move the thermal imaging and basically get thermal and color image to be calibrated when the distance changes. And then, so I mean, all that's kind of working right now. We only have a few more software fixes to get done before this guy's fully supported. One other thing we added a buzzer. Just because we thought they'd be cool for people to be able to have some kind of audio output for simple warnings. And you also have battery charging support. So when it's plugged into USB, it'll charge the battery and run off that battery. I can't say this thing's going to be cheap, but it's actually designed as a professional product for people to build hardware that's integrated into real applications. So like all the IOs are actually protected via TSV diodes and et cetera. The whole idea is we want people to buy this platform and then build it and make thermal applications that they can actually put out in the real world. So an example is, do you want to make a DIY COVID camera? You can do that now with this thing. Do you want to make a thermal sensor that's sitting up, in some environment and sensing something and outputting that to a display or outputting that via Wi-Fi?
Or sounding a buzzer if a part gets too hot or something.
Yeah,
I could see that just for like soldering stuff on a hot plate or something if your chip is in danger.
And so, that's the idea behind this system. And, assuming it's successful, we'll probably start making smaller variants that aren't as ridiculous for more targeted applications. But, right now we're just trying to make the biggest, most complicated thing that shows off the most features before we would shrink it down to something that's smaller per customer request. We wanted to really get out there and show off what the platform can do.
Well, I'm sure you'll be successful because you've already had several campaigns that your shop is doing really well. People use I see OpenMV stuff everywhere. And you already had a Kickstarter back in, what was it, 2015 or something that was also quite successful. So
yeah, hopefully. This thing will cost a little bit more. But what we've noticed is that people who want to play with thermal are actually interested in performance versus keeping the price low. So that's what we're trying to go for. Okay, let me show off a demo of this.
Please.
Is that okay?
Absolutely.
How do I share just... don't want to share...
Oh, if you do the screen share, then you can choose the window.
Oh, okay, sweet. That's great.
I have the same thing. I don't want you to see all 8 billion tabs.
Yeah, can you see my screen? Awesome. Okay, so this is PureThermal. So I want to show off just how simple this script is. This is a 38-line script that is going to do output from the thermal camera and output it to an LCD and be able to sense objects.
Wow. Oh, look at that.
So this one doesn't have the distance sensor, so you can see the problem is that you can't really calibrate the thermal location. Obviously, as you go farther away, the images line up because of the infinite distance. But as you get closer, though, being able to actually tell the distance to whatever you're looking at is quite important. But what's cool though is you really get the ability though to like have the thermal image, referred back to the real world. So like if I'm touching the piece of wood, you can see, my palm prints still being there on the wood. You can see my hand heat signature still on the armrest. You can see the heat signature still on the mouse there. And you can kind of see a Raspberry Pi over here, and you can kind of see the heat's coming off on it. You can also see how like you see how the main processor has this like, you can kind of see how it's like shifted a little bit. Notice how the main processor doesn't appear hot, and that's because it's made out of metal, and so that metal is reflecting actually the heat, and so it doesn't appear hot because the heat reflects off of it, so you can't measure it using IR radiation. But these are the kinds of things though. So like looking at my screen, for example, you can see the LCD driver and the bottom of the screen is where the heat is. Or looking at my camera.
I'm losing it over here. This is so cool. As an artist, I'm just like, it's amazing. It's perfect already.
Yeah, so that's the idea, is that you get this kind of thermal overlay effect. And so,
that is so cool.
This is also coming out on a screen. So if you look at my, let me stop. Yeah, so if you look at my screen, right? Oh, there's a little bit of reflection there, but if you look at my screen, you can kind of see, yeah, you can kind of see my face, and this is happening at the same time as it's streaming to the USB on the computer. It's also going to this touch screen back here. And then thirdly, you can also stream that at the same time directly to the HDMI out, which can be mirrored.
That's so
and
cool.
finally, if you wanted to add even another load, you can do RTSP video also. So you could have, over USB to the screen, to RTSP video, and to and your
built-in panel there.
Yeah. So a lot of different ways to have it output, and that's just an example of the default mechanism to be able to read thermal images and such.
Wow. And with that touch screen, do you have any interactions already programmed, or is that like, I could imagine like a touch to autofocus or something on a particular point?
Oh yeah, you could do that if you wanted to. Well, it wouldn't be like the camera just has one autofocus feature, so it wouldn't be like you could tell it where to, but
okay, yeah.
Yeah, but you can still like touch the screen and cause it to autofocus and like draw a button.
Cool.
I would say like our GUI library is not, let's see if this camera is going to autofocus. There we go. Yeah, but I mean, you could pretty much have it set up where there's a button you can display that would cause it to autofocus, and you could probably adjust the scaling on how, because once we have that distance sensor working, you could probably have a little slider that adjusts the parallax effect of how it's mapping the thermal image between the color camera.
Yeah.
Mm-hmm.
That's so cool. Let me pull this up. So everyone, again, we are talking about the PureThermal new camera from OpenMV. You should sign up now to get notified when it launches. We'll put that link in the description. And you'd already been working with some thermal, like you had this FLIR lepton adapter module that people could stick different FLIR cameras in. And you also had a cool global shutter camera module. Does the PureThermal have a global shutter?
No, it's not going to have that feature. It's just FPC OV5640. We didn't decide to go for all of that because it's just
you have to make some choices.
Yeah, we have to make some choices on what we're supporting, but the FPC camera module has that nice feature of autofocus. Like with our normal cameras, it's just a fixed lens, so you can't really command this lens to change its focus because there's no motorization there at all. So it's just going to be this image, and that's about it. But yeah, no, we have FLIR lepton support. for the regular OpenMV Cam. So this has been out for a while. So you can basically add a FLIR lepton to the OpenMV Cam and output data, take thermal images. What we noticed is that almost everyone would ask us, hey, we want to do color and thermal images combined. And so that's where we got this idea of how can we do both at the same time. Yeah.
Right. So what are some of your favorite ways that people have used these in the past? Any OpenMV products?
Any OpenMV product? Oh,
What are
wow.
your favorite applications? I know it's a huge question.
Honestly, I think the best one I saw so far was one of our customers, Mike. He made if you want to search for this, he made he did a long blog post, and it is about using the OpenMV Cam as a star finder.
Ooh.
Yeah, pull it up.
Is this the auto guider for astrophotography?
Yes, it is.
Wow.
He put a link though. There's like a no. Go to Google search it, and you'll find there's a link to a. Yeah.
I'm having a little bit of trouble, but I wonder if you could
Let me pull
find
it
it.
up.
Cool. Oh wait, Starfinder SRD open source? No. I've seen these on.
Okay, I found it. I got the link.
Oh, there we go. Cool. I can say I've seen these on.
Okay, there's the link. I just sent it to you. Pull it up.
1 second. This is taking a second. Thank you for your patience, everybody. I'm gonna put it in my other browser here, and we're gonna pull it up. Ooh, look at that. Yes.
Okay, so if you scroll down, he wrote this incredibly long readme. Yeah. So what he did is, I didn't even know you could push the system this far, but he more or less wrote a private web server with the OpenMV Cam using our Wi-Fi shield that serves up, it serves up custom code. It serves up web pages, right?
Mm-hmm.
And then he's able to take that image data from the OpenMV Cam and the custom web pages he's serving up over the Wi-Fi shield. And he's not serving up simple web pages, but he's serving up ones that have lots of JavaScript and asynchronous callbacks so that you can click on buttons and things happen as you're doing that. And the camera is just there by itself, and it's serving that web page, and it is actually running a star finding algorithm. So given the stars it sees in the sky, it'll figure out where you are located and where you're pointing.
Wow.
And I was just blown away by how much of an application he did. But here's the reason why he decided to use our system to do this, because he's trying to build a commercial product in the end. And so what the OpenMV Cam offers is that we are fundamentally a microcontroller-based platform that uses parts you're allowed to buy yourself on the market. That's how you can see that, we built the OpenMV Cam PureThermal. It has much of the same components as this previous board, as the board that he used right there. And so when he gets done with his software development, he can more or less go out and choose to take our design, remix that into exactly the form factor he wants with the exact components he wants. And he will still receive the ability to, get firmware updates for free from us and things fixed. But he'll be able to control the entire hardware package without having to be dependent on anyone else for buying components from him.
That's super cool, and that's where the open part comes in. It's amazing. It's such a cool model.
Yeah, and so he starts off with a dev board, and that gets him to where he wants to go. And then once he has everything working, he can then say, okay, I'm going to do a custom hardware design, make it just exactly what I need, and then put that into a product and go to market with it.
So yeah, speaking of productizing, I'm interested. You've done a Kickstarter, you've done direct sales through your website, and now you're doing a group gets buy. I'm really curious about how your business model and you've tried so many different things, and it's interesting to see how it's evolved. I'm curious what your thoughts on that are.
Oh,
How you run the business.
yeah. So we put a Shopify store up, and we've been selling OpenMV cams to the Shopify store. And we started working with distributors to kind of get the camera out to more places. And more or less, it's just kind of organically been growing. So people and companies are buying the product and they're building it into random things. Because we open source the system, it's not like we capture all sales, because people just go off and build it themselves when they want to. But we try to do the best we can on providing a constant source of boards for folks to work with. And some companies prefer to just buy from us versus building the hardware themselves. And then what we also did is, in order to kind of keep cloning not insane, because that's like, we saw what happened to Arduino, where the Arduino, the Uno was cloned relentlessly, and it's one of basically the most popular product.
Yeah.
We didn't want that to happen to us, so our IDE actually enforces licensing. Pretty much, if you buy a clone, it kind of asks you for some money. Some people might think, hey, that's not great, that's not supporting open source, but at the same time, it's kind of like, well, this is what funds us continuing to work on software. Because at the end of the day, a lot of the stuff I mentioned on improving the processor performance and making it go faster, that's really hard, and it takes a lot of effort and time to devote to that. And it wouldn't be it'd be really hard to justify cranking really, really hard on this project and trying hard to like push the performance higher if the company is really not succeeding at all, and it's just you're relentlessly getting cloned, but there's no value being captured for you.
Absolutely.
So, and also it's like we've had to, in order to even like realize that it was possible to go to a higher performance, we had to pay a performance optimizer to really show us the light there. I didn't understand that previously, like a year ago. I didn't realize that I had done a not great job on the software. I thought I had written, effective software that was clear and pushed the processor and did everything as best as it could using C. But okay, do you want to go on a weird tangent?
Sure.
Okay. So let's go to what I mean by that. I think this is something everyone should know about. It's quite useful to get good at that. Okay, can you see my screen? Some ugly C code.
Here we go.
Yeah. So here's an example of this in the most perfect detail. This is the TV driver we wrote. And so it took me like a week of rewriting this and checking things. And it's like, this is a lot of effort to change things drivers and make them high performance. But again, though, the benefit is now people can really utilize this and do their applications without having to worry about things not performing as well as they could. But anyway, what I wanted to show off is an example of double pumping. So when we started this job, like this is how I used to write code. So this is a function that takes a row of pixels that are in a format called RGB565, and it has to convert them to YUV. And so in order to do that, we have just simple code that grabs a pixel, extracts the RGB components from it, and then converts that to YUV. And we got some macros to do that. And so these macros were originally the way I wrote them was I had a floating point multiply for each part of the YUV conversion. So YUV is just a very simple, something called a color matrix where you, let me show that off real quick.
I wonder if it's possible to up the font size a little bit, or if
sorry, let me do that. Yeah, it is. I apologize. I'm doing.
No prob. I have this tiny window.
yeah. Let me just make that real big on you.
Nice.
20. Okay.
Oh yeah, there we go.
All right.
Oh yeah.
Can you read it now?
I can even read it on my little preview screen, which is amazing.
Okay, great. So this is an example of code I used to write. So one thing to note about performance optimization is to think about the most inner loop of an algorithm. If you can just shave off one or two instructions off the inner loop of an algorithm, you will dramatically increase the performance of any particular algorithm that you're designing, or that you have. Like the outer loops don't really matter so much, but if you can make that inner loop really, really tight, then you will see huge performance gains. Because the inner loop is what gets run the most. It's like a reactor core. If you focus on making the reactor faster, you'll get huge performance gains, and these then translate into power savings because your processor can go into a low power mode quicker. Right. So this is how I used to write code. I grab one pixel at a time. I do the RGB conversion. So RGB 8. So RGB 565 is 16 bits per pixel with 5 bits for red, 6 bits for green, and 5 bits for blue, and they're kind of packed into 16 bits. And then you have a little algorithm, a little function that converts that to red, green, and blue to extract an 8-bit version of that with the zeros, the bottom bits kind of replicated from the top. And then you can do the YUV conversion. So YUV conversions are just, it's just basically you multiply each component by a number, and then you divide by something. So it's like you're doing this formula on the red, green, and blue, and you're doing this on red, green, and blue, and this on red, green, and blue for the different components. So it's a 3x3 matrix multiply. So first, when I first wrote this code, I straight up just said, okay, I want it to be as precise as possible. I'm going to use floating point multiplies. And so I literally gave the processor, I just said, let's multiply red by 0.5, green by this, and blue by that, because I want it to be exact, I want it to be right, I want it to be correct. Well, it happens to be that floating point multiplies are not that fast on a microcontroller. It is almost 5 times faster to multiply by these constants and then shift right for a divide by 128. It is much faster to do that. And when you're doing this over, 1 million pixels in an image, that results in a huge performance boost by not using floating point numbers when possible. Because note that GCC, for example, when you use floating point numbers of GCC or any compiler, there's not that many tricks it can play on speeding things up, but when you use everything in integer math, there's all kinds of fun stuff it can do in order to make things faster. But then this is still, even at this level of optimization, you're still, not really utilizing the processor effectively. So then you can uglify it. Okay, so this is the level of optimization that I finally leveled up to, and I only realized that this was possible after working with a professional performance optimizer and learning how to write fast code. And when you get to this level, you start to see, again, large boost in performance. And this is doable through you realizing how the processor works internally.
Yeah.
And kind of breaking the shackles that, in computer science classes, you have a certain mental shackle on you because you've been told to write code that's very straightforward and ignores what the processor looks like internally and what it's capable of doing. And you don't think about how you can, parallelize things using how the microarchitecture is built. An example, instead of loading 1 pixel at a time, you can, treat a pointer as a 32-bit number and load 2 pixels at once into a 32-bit register, right? So now you've got 2 pixels in a 32-bit register because each pixel is 16 bits. And then so if I want to extract the red, green, and blue components, I can basically shift some things around in order to extract red, green, and blue, and then also align them into the right locations in order to have them go from RGB 565 to RGB 888. And so this is doing the pixel extractions in parallel for both pixels, updating them from the 5 bits to 8 bits. Again, so I am double pumping the processor now. I am doing 2 pixel operations every single instruction. Now, if you know about the ARM architecture, shifts are basically free in the ARM architecture because it actually encodes those into the opcodes. So And then when you have constants like this in the ARM architecture, those can be encoded as, those don't have to be stored as a separate word in assembly, but they can actually be encoded into an instruction too. And so when GCC, for example, sees things like this, it optimizes the heck out of it. It's like, thank you, you've given me something very, very easy that I can produce the most optimal assembly code for now. And so GCC will produce some incredibly tight instructions for that. Next, the nice performance thing you can realize is, okay, I see that now that I know that I have, like what you're imagining in the register now, it kind of looks like this. You would have something like a pixel, right? 00 pixel, 00 pixel. So that's what's in the register at this point in a 32-bit reg. And so what I realize now is that a multiply, for example, that's going to cause, if you multiply these two 16-bit numbers that are in the same register by a constant,
Right.
it won't overflow into each other, right? So you can multiply these and by 38, 75, and 15 separately, and add those all together, and it will be like the bits won't, from the bottom 16 bits to the top 16 bits, won't touch each other, won't overflow into each other.
Nice.
So that again lets you do the multiplies. You are getting 2x the work out of one multiply instruction that you are doing. And then you can shift them down. And while this makes the bits run into each other, you know, though, that you didn't shift, it doesn't matter because you're going to extract just a particular component. Now, for doing the other operations, you have to worry about the fact that you're doing subtracts. And subtracts will obviously cause the bits, the fact that you're abusing the fact of the register having 2 pixels in it to break. But the ARM designers, though, they thought about this, and they added instructions that allow you to split a 32-bit reg into two 16-bit values that won't, and then subtract both those 16-bit parts of the register separately, such that they won't overflow into each other. So what this code does is it does the same YUV multiply that we had before, but it's totally in parallel now. We are doing 2 pixels per clock, right? And then there are some assembly instructions that they have built in that allow you to extract 8 bits. What this does is this says rotate the register by 16 bits and then extract the bottom 8 bits and then and then zero out the top 24 bits. And so that is one assembly instruction in ARM. And then finally, there's this instruction called SUMAD. And what this will do is take a register that's 32 bits, break that into 2 16-bit chunks, multiply it by another register that it breaks into 2 16-bit chunks, add the results together. And so this allows you to do the same thing as adding these 2 values, but doing 2 adds in parallel, more or less. So just getting into that format where you're writing code like this is what kind of allows you to, again, achieve an even higher performance boost on what you have currently running. But it really requires you to kind of get down and dirty into how the processor works and what's happening.
That is so cool. I feel like I just had a little mini masterclass. And I actually followed what you were saying about assembly and like shift registers and stuff, and that's really cool. I would love.
No one thinks like that, though. It's very much like, even going to school, you barely get introduced to what kind of performance you leave on the table when you write code. You're just kind of like, okay, I'm just going to write it in a straightforward manner that's easy to read, and it's cool, and you don't think about it too much. And it does matter, though, because when you're leaving 2x performance on the table or 4x performance on the table, it means you need a 4x faster processor to run the same code, right? So, getting into these details matters for if you want to like utilize things as good as possible, and especially if I'm a library developer, so it's really upon me to kind of take that knowledge in and figure out how to best equip my users so that they can do things really well.
Yeah, and it's really interesting how your business model kind of enables this. So, because I know that you've been doing this on top of, like, during the time that I've known you, you've been doing this on top of other, like, actual, like, full-time jobs, which is just incredible to me. Are you still doing that, or is this your whole thing now, or like?
Yeah, no, this is side hustle still.
Man, no
It's
way.
yeah. I mean, we don't get a lot done. You know, like we're not like crazily updating the code and doing tons of work, but I mean, we are definitely we're definitely still chugging along, and we landed a partnership with Arduino, where we're developing software for the Arduino Portenta now, for example, that more or less get our same OpenMV Cam functionality running on it.
And you can find out about all that on your news page. Yeah. So what's with this new release with the PureThermal, everybody were talking about the PureThermal camera, which is coming up on GroupGets.
Yeah.
What do you think are like the pros and cons of different types of funding that you've explored? I sort of asked you about this vaguely earlier, but like between, you know, Kickstarters and GroupGets and like direct Shopify stuff, like do you feel like they have different applications that you use in different times, or?
Yeah. So Kickstarter funding sucks real hard. And the reason for that is it's kind of like so Kickstarter funding, the thing is, like, it's so much work to put a campaign together, and it's really not the case that people doing campaigns are kind of full-time jobbing in it a little bit. And you know, if you're doing it as a side thing, it's really kind of like the bar is set really high at this point. Like when Kickstarter first started, it was kind of like the bar is pretty low. You know, just put your idea out there and see what happens. And that's how people were blown away by, oh wow, this guy did almost no work and got all this money to do his idea. Nowadays, it's very much like you're competing against professional companies who receive funding beforehand.
Yeah, and they do it as kind of a
Kickstarter up. So the Kickstarter is just their marketing launch.
Yeah.
It makes it hard to compete with them through that, because the way they present themselves and what they're going to do to drive traffic is just such it's such a different thing than what you're doing what resources you have if you're just doing it on your side in your free time. Kickstarter, well, it's good for launching. They have an excellent, like, you have to use them in order to get the most PR, to get the most clicks. But I would say fulfillment with Kickstarter is really a nightmare. We 100% love Shopify. Excellent platform. It's been amazing. We would have gone out of business without using them. But it would have been nice. It would be nice, for example, and if anyone's from Kickstarter is listening to this, can Kickstarter folks make a Shopify plugin that takes the orders from Kickstarter and then imports them into Shopify? Because we have, you know, when we do our Kickstarter fundraise, serious issues with data on what users provided to us. Just like incomplete addresses and bad addresses. Nothing was validated. Shopify, for example, does this very simple thing in that you can't enter an address that doesn't exist. Doesn't sound like a big deal who enters addresses that don't exist, but a lot of people will do things that really make fulfillment challenging if they enter their address with the wrong kind of Unicode, and you just end up with like crazy characters in your spreadsheet.
Oh no.
So just they make that easy. They make order fulfillment easy. And there's also like a whole customer relationship management thing where you can see each customer and what they bought and their orders. And all that stuff just makes it easy to answer questions quickly and figure out who paid for what and what is ordered, and et cetera. That's a huge nightmare of admin work, honestly, when you run a Kickstarter. So I'm very much just like, I never want to do that again. It's just it's so stressful, and it takes away so much time from just working on the product. We more or less have our Shopify store set up with a drop shipping fulfillment. And so we don't have to worry about the day-to-day works of shipping products. We just have a fulfillment center take care of that for us. And then we just have to make sure to pay our contract manufacturer to continue producing new units and putting them in a warehouse.
Awesome. And
then the reason why the PureThermal is being launched on the GroupGets campaign is because it's GroupGets design. That's why it's called the OpenMV PureThermal like GitLab and group kits, because it's literally a board design they're making. So that's just how they like to launch things.
Ah, that's cool. And you
Yeah.
also, oh, sorry, go on.
Oh yeah, no, it's not. I'm saying it's not really like I mean, they've helped develop it and pay for the development, so it's not a.
Ah,
It's not like we're just throwing things at the wall per se over there. It's like, we've thought about this and this. That's just how they go about, doing their pre-sale process.
that makes sense.
Yeah.
You also have a collaboration with Singtown, which is an interesting model to me because I haven't seen that kind of a thing before. Can you tell us about what that's like?
Oh yeah. So Kazi and Yan, they're both in China, and they have been fans of the OpenMV Cam project since we started. And more or less, they built out an education environment for people in China to more or less utilize the OpenMV Cam.
Oh, that's so cool.
So, yeah. And so they, they've been really awesome in that they actually cared about keeping the project healthy and not just, kind of sucking funds from it. An example, there are some cloners who literally rip off the project totally 100%.
Oh no.
And
right.
don't want to pay any royalty fees back to us. And that's cool and whatnot, but when you do that, it's kind of like it'd be hard for me and my co-founder to really justify the amount of time we spend. And like after 6 years, it's kind of like,
Exactly, yeah.
You can't really. It'd be hard to like. I have to actually dedicate myself to this pretty thoroughly, and so all these performance optimizations you're seeing and things like that. Like these are all functions of it actually being a working business. And so when people are enjoying the fruits of the labor that's been put into this, and how things have gotten better and better and better, and all the great open source software we're developing, that is a function of a business working. And so when you have a lot of cloners just coming in and stealing all of the actual revenue that keeps the business alive, because note it costs like money to keep those documents, the docs hosted, to run our website, to get SSL securing. Cloudflare, for example, charges you $200 a month.
Whoa, for SSL.
Yeah.
Wow.
So it vary, and then server cost, and if you were out of pocketing this just from your day job, you'd be easily a couple grand a month in terms of trying to keep all these assets alive. So it's not like you can just do all this for free. And
plus what you're talking about, paying the optimizer person.
Yeah, it's 125 an hour. So I mean,
maybe I should get that too.
Yeah, I mean, I want to see a future where it's like, I love open source software, but I want to see really excellent open source software being released. That it's like, we really tried to put the best effort into this, and it's not just like this is the stepping stone, and then there's like some secret custom stuff that a company has internally that they never share, because that's actually really good. I'd love for that.
Or that like you're gonna at some point sort of throw the community under the bus and like take it to just like sell the company and take it private, which you've seen a couple of times.
Yeah. So I want to avoid that situation. So having a healthy company is what allows that. Anyway, so Singtown, they more or less decided they wanted to see a healthy ecosystem.
Yeah.
So they've been awesome in that they actually contribute back to OpenMV. They actually, send licensing revenue back to OpenMV, and that allows us to continue operating. And it's really helped shore up finances, honestly, because I've sometimes messed up the pricing on the camera and exactly how much money you make and how much it costs to ship and build it. And so having license revenue has definitely made it much easier not to run out of cash.
Awesome. I love all these different ways that you find ways to keep the company alive and make it worthwhile for you as someone who's doing a whole other job and make that be sustainable. It's so awesome. Thank you also for the amazing lesson in optimization and all this cool stuff about the PureThermal, the live demo. Amazing. Thank you so much for joining.
Yeah. Thank you. This has been an excellent interview. You got any other questions? Any questions from the community?
We do have questions from the community. So we have a comment from James Newton who's talking. It's very large. It's about how you can. It's like a site that tells you some of the things that Kwabena has been talking about with optimization, which actually answers a question from the embedded whiz about what resources can I use to develop optimized embedded code. They kind of answer each other, in my opinion.
Let me see what that link has. Multiply div.
Yeah, you can put it up if you like.
Okay. Well, that is that's for the pick. So that's kind of like that's cool, but that's like back in the day level optimization for microcontrollers without hardware multiplier divides. So ARM has hardware multiplier and divides. So we're not like worried too much about trying to make the multiply and divide algorithm faster. We're actually worried now, like how can you actually write like real SIMD like code where you are doing multiple pixels per clock cycle, double pumping things. Like how can you actually go about doing that? And so this is like a higher level that I don't think a lot of people actually cover, just because it's kind of, I mean, you really have to get into serious like architecture abuses and breaking the shackles of like how you think about C code.
I love how you put that, yeah. And then we have a couple of comments that are just like, hey, it's so cool, which is true. It is so cool. And hi from Tunisia. It's awesome. I love that people join from all over to watch this stuff, and I love that you make it possible. And it makes Tuesdays the best part of my week. Honestly, this is rad. And you're welcome on, of course, anytime to talk about new things. Oh, you also have coming up TinyML Summit. I heard.
Yeah, I'm so busy. I don't. People have been inviting me to things, and I say yes, but I don't know what's going on really.
So, where can people follow to find out what you're up to?
Just sign up for our blog and our Twitter. We try to post information that's relevant. I don't post like everything, like as I'm going about it, because it's a lot of hard work to get things done, and so I don't have the bandwidth just to constantly post. But we have our Twitter and we have our blog, and so you can just follow along and see what we're doing there.
Great.
Like, the recent thing I published was we got the JPEG compression performance up by 2.5 times faster now.
Awesome. So you can follow on Twitter, linked below, at OpenMV Cam, and at OpenMV.io, you'll find the blog in a tab at the top. You can go subscribe there. You've got a little RSS boy as well. Cool. Or Adam. Sweet. Well, thanks again, and come on again anytime you like, even though you're already so busy. We always like to hear from you.
Okay, thank you so much.
Next time I'm going to ask you about the space communication satellites thing, because you told this really cool story one time, and we don't have time right now, but
that's probably not something I can share about.
Okay. Never mind then. Anyway, cool. Awesome. Thanks, everyone. We'll see you.